All right, so 8.1 here, pre-calculus 30. We're looking at logarithms here, and in 8.1 we are talking about in question number 1 in your assignment. We're talking about an exponential function. So here we have y equals 2 to the power of x. And the first part says copy the grid on a graph on a grid paper, then sketch the graph of the inverse on the same grid. Okay, so I'm just going to work with this one a little bit here on this grid. So the inverse, remember, inverse means reverse, and so we need to reverse the x and the y. So watch this. If the exponential form looks like this right here, then we need to write the logarithmic form in this fashion. So y here and x here, and the base is c. So this one right here, y equals 2 to the power of x. So what we're going to do to make it a logarithmic form, and I know we don't have to do this quite yet. This is number 2, but I'm just going to skip to number 2. So we have the y is the exponent now. So, right? So y equals log of, and then whatever log of, this is going to be x now. So log x, and then the big thing is base what? The base of the exponential function is the base of the log function. So that's base 2. So y equals log of x base 2. That's what this is transformed into, really. So let's do this in red. So if we have a point 1, 2 right here, this is 1, 2. So I'm going to go 2, say 1, 2, it becomes 2, 1. Okay. 0, 1 becomes 1, 0. And so what you end up having is, if you remember, you have this, I'm going to make this a different color, but you have this y equals x line right here that is the reflection line. It's like the mirror. And the graphs are reflected in this line. So notice that we're about, half a square away from the line here. So this one is half a square away as well, same distance. This point right here, this point right here. So this point over here, let's say, well, I don't have that one. So let's say this point right here. Okay, so 2, 4 becomes 4, 2. And so just like this is kind of going up and away, this one is kind of turning into this. Okay. Now down here, this is getting close to 0. So this is getting close to, this one's getting close to y equals 0. So this one's getting close to x equals 0. Like that. Not touching the line, but getting close. So that's sort of what the graph looks like. And this could be extended, of course. But that's what the log graph looks like. Okay. And here you have, so this is it right here, actually, right? This is the exact one from your key ideas. So it's a reflection about this line, just like this right over here. All right, so that's 1 and 2. Okay, so 1 and 2. And then for 3 here, determine the following characteristics of the inverse. So the domain and range. Okay, you can just kind of look back to this this key idea here as well. But for point number 3, the domain, notice that this red graph doesn't extend into the negative x part. Okay, 0 is not included and the negative x part's not included. So that means that we have a domain of x is greater than 0. And that's all you need to put for me, right? You don't have to put comma xer. You can, but you don't have to. So, right, it's greater than 0. The y, this is going to go down forever, and this is going to keep creeping up forever. So the range here is y is an element of all real numbers. It's everything. The x-intercept is 1, 0. Okay, that's 1, 0 for the x-intercept right here. The y-intercept does not exist. Okay, you can write that down, does not exist. And the equation of the asymptote. So the asymptote is either horizontal, which it is for a exponential function, or it's vertical for a log function. So the asymptote here is this x equals 0 because the graph comes up to it but doesn't touch it or cross it. So the asymptote is x equals 0. So that's for one. That's 1A, just to get you started, and it helps that all the information really is here on the key ideas. So that's 8.1 1A.